So we talked a little bit about enzymes when we were talking about your lab last week, but I just wanted to go back and give you a few more details about enzymes. So enzymes are a protein, and the whole purpose of them is to speed up how quickly a chemical reaction takes place. Remember, in the last lecture we were talking about chemical reactions, and a chemical reaction could look something like this. I have reactants on this side, I have products on this side. Whatever atoms and elements I have over here, I have the same number of atoms of each element on this side. So over here I have 12 carbons. On this side I have 6 carbons here and 6 carbons here for a total of 12 carbons. Here I have 22 hydrogens plus 2 more hydrogens for a total of 24. So on this side I have 12 hydrogens and 12 hydrogens for a total of 24. Here in my oxygens, I have 11 oxygens and 1 oxygen for a total of 12. Here I have 6 and 6 oxygens for a total of 12. So same thing, we have our chemical reaction with our reactants and our products. And naturally, this reaction would happen. Sucrose can come together with water and it will form glucose and fructose. That just naturally happens. But it takes a lot of energy. And if we were to add an enzyme, this chemical reaction would go much faster because it wouldn't require as much energy. And that's what these graphs are showing us. So here's the reactants, and it takes a lot of energy to get it to be able to make the products, naturally. Here's our reactants. It takes a lot of energy to make these products. But if I were to add an enzyme, I have the same reactants, but it wouldn't take nearly as much energy to make the products. What I want you to understand, though, is that the enzyme is added, it's not part of the reaction. So I have sucrose and water, neither one of those are enzymes, and I have glucose and fructose, and neither one of those are enzymes. These are reactants, these are products, and if you add some enzyme to it, these reactants will make these products just faster because you've added the enzyme. So what does that look like? This was your notes, and we talked about this in the lab. And so I have a kind of a bigger picture here for you. So here's my enzyme. The substrate is going to be the reactant in the chemical reaction. So it would be like this stuff here. The reactant is the same thing as the substrate. And so the substrate is going to make my product, just like my reactants are going to make my product. And it's going to happen, but it takes a lot of energy to do so. But if I add this enzyme, the substrate or the reactant will fit together on the enzyme at a location called the active site, and it will allow us to make our products much faster because it doesn't take nearly as much energy to make those products. This substrate is going to be very specific to the enzyme. The reason it's very specific, they say it fits together like a lock and a key. So just like your key will only fit in the door, the lock on the door on your house, same thing is true with a substrate. This substrate will only fit together with this enzyme to make this product. And like I said, all it does is make that product faster because it doesn't use as much energy. Also, the enzyme never gets used up. I use this enzyme to change this substrate into the product, but I can use this enzyme over and over and over again, and it never gets used up. So again, here is another chemical reaction that we can look at where we have our reactants and our products. What I want you to know is that you can take a molecule that's already together and separate them using an enzyme, or you can take two molecules that are separate and put them together using an enzyme. The other thing I wanted to point out on this slide is that if you see an enzyme, it is going to end in ase. So this is my enzyme name right here. So here's my purple enzyme, and it is called sucrase. The sucrase ends in an ASE, so that's how I know that it is an enzyme. And usually the first part of the word tells you what it works on. So sucrase is the enzyme that works on sucrose. So naturally, sucrose and water are going to break down into glucose and fructose. But if I add sucrase, it will happen much faster and without the input of energy. So enzymes are great. They do a really good job of making chemical reactions happen a lot faster. But they're also very wimpy. They like their perfect environment. These graphs show you when enzymes work well and when they don't work well. So pH is like how acidic or how basic something is. And if the pH of the environment is too low, the enzyme isn't going to work very well. The pH of the environment has to be just perfect for the enzyme to work its best. And if the pH starts to get high, then the enzyme doesn't work again. Temperature is a little bit different. When you increase temperature, molecules start moving around much faster. And so if we look at this picture here, these molecules will be moving around really fast as the temperature is increasing. When the temperature is colder, the molecules are going to be moving around much slower. So if I increase the temperature, these molecules are going to be moving around much faster and are more likely to bump into the enzyme and attach at its active site. And that's true until it reaches its perfect temperature. At this temperature right here, the enzyme is very happy. The substrates are moving around really fast enough to accidentally bonk into the enzyme, but it's also a good temperature for the enzyme to all stay together. If the temperature gets too hot, the enzyme will denature. Denature means you are changing the shape of the active site. So if we go back here and we remember the active site is where my substrate will fit, if the temperature gets too hot, this active site changes shape and my substrate can't fit in there anymore. And that was what happened when you guys were doing that carrot lab, where you had the cooked carrot and the enzyme didn't work anymore. It's because you had denatured the enzyme, the catalase enzyme that was in the carrot. And last but not least, substrate concentration. So remember, the substrate is the beginning part of the chemical reaction up here. And if you don't have very much substrate, the enzyme isn't going to work as fast. You need to have plenty of substrate so that it's more likely to bonk into the enzyme. And once it reaches a certain amount of substrate, then the enzyme can only work as fast as it can, because only one substrate can come in contact with the enzyme at a time. Then, last but not least, I made you guys a video already about your carrot lab. So the link is right here for that. So remember to go back and watch that if you need some extra help on the explanation of how the enzyme was working and why it was working best before the carrot had been cooked.